open source is usable in whole or in part. So, where code is provided as part of something else, the code can be redistributed and used independent of the whole code originally provided. This is great. Open source software allows you to use, reuse, and recycle code in line with the SDGs and saves a huge amount of time and money in creating code. This is helpful to our governments as they build digital infrastructure, and particularly helpful in emerging economies where they can replicate and build on existing open source software, saving time and money for you. When you contribute to code, you add your own name to the header in the code as the owner of the copyright. Do you remember copyright and licensing? The header in the code is where we manage licensing and also this recognition or attribution of the code creator. Almost all open source licenses require this attribution. We write which license applies to the code and who has made the code. Attribution is adding someone's name as the creator. Of course, all of this is done across the globe in a distributed and collaborative way through Git repositories like GitHub and GitLab. If you contribute enough code, then you can become well known in the open source community and might be known as a coding rock star. Yes, that's a real thing. A bit like Imogen Heap, our singer friend, who was the inspiration for the glove. Well, sort of, in a coding sense at least. Building a reputation in open source contributions becomes your CV or portfolio of work and could help you find a job someday. Maybe you're a little young to be looking at that now, but many open source developers started to contribute to coding when they were teenagers. Some of you are also gamers, and maybe you would prefer to think about how your reputation as a top gamer could spread on Twitch instead. Being a rockstar gamer is similar. Code is not always perfect. People can improve it for you. And don't worry, if you make mistakes in public, that's a good thing. People expect to see your mistakes, even future employers. And watch how you improve as you develop your skills. We all make mistakes, and that's how we learn. You can always come back and improve it at a later date. This shows your learning and growth. Or maybe someone in the community will help you out and spot and fix a bug for you. In this lesson, you will learn that open source code can be used in whole or in part, that code contributions should be attributed with the code license in the header, how to use the turtle module in Python. It's time for another Python project. Let's start off by heading to a different code editor at https://create.withcode.uk. The website has a built-in Python simulator. Today, we're going to be creating some art with the Python Turtle module. The Turtle module is great for creating fun shapes and drawings. Let's start with a fresh canvas. Delete any pre-existing code and we'll get started. We'll begin by importing the modules we want to use, the microbit module and the turtle module. Once we've written that, go ahead and click the green play button. This will run our code. Notice how a panel on the right-hand side has popped up. This contains our simulator and a blank white canvas. This is where we will be creating our art. Time to create our turtle. This is what we will be using to draw lines. It's effectively like a pen. We can tell it to go forwards or backwards, turn left or right, or put pen up and down when we want to move to another space on the canvas without drawing something, like taking our pen off the page when we move it to the next line to continue writing. We'll create our turtle using this next line. T is what we're calling our turtle. You know, T for turtle? We set it equal to turtle.turtle. That's a lot of turtles. The first turtle is the module. The second turtle says to create a new turtle. Now, if we want our turtle to do anything, we can refer to him by his name, T. Let's think about what we want our program to do. When we tilt the microbit left, let's get our turtle to turn left. And when we tilt right, we'll get our turtle to turn right. When we tilt the microbit up, we'll have our turtle move forwards, and likewise, when we tilt the microbit down, we'll move the turtle backwards. We'll start off by creating a forever loop by writing while true. Don't forget the colon after the word true. Python's very fussy with that sort of thing and making sure that you are exact, as you no doubt remember from lesson 3 and 4. We're going to have a series of if, elif, else statements for our turning left and right and moving backwards and forwards. We're using accelerometer.was_gesture again. If you can't remember, the accelerator.was_gesture finds whether the microbit has been moved and how. The input parameter is the name of the gesture. For example, left, which checks if the microbit has been tilted left and returns true if it has been, or false if it hasn't. In this case, we have 5 statements. After checking if the microbit has done a gesture using accelerator.was_gesture, we move our turtle to match. To turn the turtle left, we use t.left and put 90 in the brackets. 90 is the number of degrees we're turning. It's the same for turning right. Moving forwards and backwards are equally straightforward. To move forwards, we use t.forward and the number of steps. You can play about with the number of steps. 25 only moves a little bit forward, but if you wrote, say, 100, our turtle would leap forward. For backwards, we use t.backward. Our final statement is to change the pen colour. The standard colour is black, but we can change the pen colour using the t.penColor command and using the colour we want to change the pen to as the input string. Here, it's green, but you could choose to put red or blue or brown or pink or, well, you get the idea. Any colour you like. Now, be careful. See how colour is spelt. C-O-L-O-R. The missing U is because this is the American spelling, just like license and license. If you try to write colour with a U, Python won't understand what you're saying. I warned you Python can be picky, and we need to get it right for our code to run. I wonder if Americans have 99s, or even flakes. OK, back to the coding. We can now press the green play button to run our code. To play about, we're going to have to click buttons to control the simulator. Click on the tab called Accelerometer above the simulator to bring up the controls. By clicking left, right, up, down and the A button on the microbit simulator, we can create some artwork. Try playing about with the angles in the turning left and right commands and the number of steps in the backwards and forwards commands and see what happens. It's great to be artistic. This lesson has been all about artists and rock stars. Creativity is surprisingly important to solving problems and good coding. Imogen Heap's creative musical skills led to the Mini Mew glove being created by her technical friend Helen Lee, who you can read about in the e-zine Hero column. Helen is a creative coder and a maker. Without both of them, we wouldn't have our gloves for the course. Collaboration is super important, and even rock stars collaborate. It's important to have all sorts of people, including very creative ones, in any community, as there are lots of different types of tasks to be done to make good code. Not just coding, but tasks like writing the documents, organising events, and designing logos are all important parts of the community. So there is plenty of space for all sorts of different skills and kinds of people. Everyone is welcome to contribute and has a place in our communities, not just the rock stars. Open source helps communities, software projects and infrastructure to develop by allowing for bits of code, like the code David shared, to be taken, used and made into something new without using the whole of the original code. That's where our creativity comes in. Code can be used to play a game, or make art like our turtle, or even to create games. Many games we all love, like Minecraft, include open source code in their code bases, the software they're built on. It's also important for sustainable development that we can use and reuse and modify parts of the whole or if we need it, the whole thing, but we have to remember to attribute and give credit to the original creators, like David. Of course, recycling is important for the planet, and we must remember to recycle for our wildlife and ocean life too. Preserving natural resources and ensuring we recycle are a big part of this. In this lesson, you have learned that open source code can be used in whole or in part, that code contributions should be attributed with the code license in the header, how to use the turtle module in Python. I wonder what your creativity will have you do next. Cowabunga!